In this problem, we're going to find V0 of t for t greater than 0 using mesh analysis. We'll use our problem-solving strategy for S-domain circuits and also loop analysis. So if we look at our circuit and our problem-solving strategy for S-domain circuits, it says step 1, find the initial conditions for the inductor and capacitor. Well, if we look, our one source is 3 U of t amps and the other one is 10 U of t volts. Those have value of 0 for t less than 0. In that case, then, all initial conditions are 0. And so all our initial conditions are 0. So the next step in our problem-solving strategy says draw the S-domain circuit. Okay, so here's the S-domain circuit. We've converted everything over to the S-domain. Step 3 is our analysis step. And here we're going to use mesh analysis. And that means we need to assign mesh currents. We have 3 meshes. So I'm going to call this one I1, this one I2, and this one down here we'll call I3. So if we look, we have 3 mesh currents, means we need to have 3 mesh equations. Anytime we have a current source in mesh analysis, we get a constraint equation. Our constraint equation is fairly simple here. I1 of S is 3 over S amps. And we'll let that be our first equation. Now, let's apply KVL to the middle mesh. And if we do that, we'll have 2S times I2 of S minus I1 of S plus 1 times I2 of S plus 2 over S times I2 minus I3, and that's equal to minus 10 over S. Now let's rearrange that, simplify it some. So we have minus 2S I1 of S plus 2S plus 1 plus 2 over S I2 minus 2 over S I3 is equal to minus 10 over S. Okay, so there's our second equation. Now we need to apply KVL to this mesh, and if we do, we'll have 2I3 plus 2 over S times I3 minus I2, and that's equal to 10 over S. So if we go in and simplify that and rearrange terms, we'll have minus 2 over S I2 plus 2 over S I3 is equal to 10 over S. There's our third equation. Now if we look at our circuit up here, we can see that V0 from the circuit, V0 of S is 2I3. So it looks like we only need to solve for I3. And to start off with, let's, for instance, take and substitute that into this equation. So as we start to solve, we're going to substitute equation 1 into equation 2 and do some simplification. So then equation 2, once we make that substitution, becomes 2S squared plus S plus 2 times I2 minus 2I3 is equal to 6S minus 10. So here's equation 2 modified. Now let's work on equation 3 sum. If we multiply through by s, for instance, it becomes minus 2i2 plus 2s plus 2i3 equal to 10. Now let's take this equation and let's solve it for I2. So now let's solve this one for I2. So if we rearrange, we'll have 2i2 is equal to 2s plus 2 times I3 minus 10, or I2 of s is s plus 1 I3 minus 5. Now let's take and now let's substitute that in here. Again, we're eliminating everything but I3, so when we do that, we'll have 2s squared plus s plus 2 times s plus 1 times I3 minus 5 minus 2 I3 of s is equal to 6s minus 10. Okay, and then working on the algebra with this, we have s squared plus 1.5s plus 1.5 times I3 is 5 times s plus 1.1. And then we can solve for I3. Then is 5 times s plus 1.1 over s squared plus 1.5s plus 1.5. And now we know V0 is 2 times that. So V0 is 10 times s plus 1.1 over s squared plus 1.5s plus 1.5. If we look at the roots of s squared plus 1.5s plus 1.5, then we'll have minus 1.5 plus or minus the square root of 1.5 squared minus 4 times 1 times 1.5 over 2. So our roots then are minus 0.75 plus or minus j 0.97. So then V0 can be written as 10 times s plus 1.1 over s plus 0.75 minus j 0.97, s plus 0.75 plus j 0.97. And then our partial fraction expansion for V0 will be K1 over s plus 0.75 minus j 0.97 plus K1 conjugate over s plus 0.75 plus j 0.97. Now the way we find K1 is we multiply through by s plus 0.75 minus j 0.97. We do that, we'll have 10 times s plus 1.1 over s plus 0.75 plus j 0.97. And we evaluated s equal minus 0.75 plus j 0.97, which is 5.32, angle of minus 19.84. So V0 of t then, remember we have a magnitude, when we have complex conjugate, our magnitude is 2 times the magnitude of K1, so we have 10.64. e to the minus 0.75t, and that comes from there, cosine 0.97t minus 19.84 degrees u of t volts. So the 10.64 is 2 times the 5.32. The 0.75 comes from here and the 0.97 from there.